Tackling the Long Context Challenge in Large Language Models. Great paper named Learning Long Contexts Offline, or LLoCO. This approach allows us to extend the effective context window of a 4K Llama to 7B model to handle up to 1 to 8K tokens. Moreover, the paper achieves state-of-the-art results that match or even surpass the performance of a Llama to 7B 3K model with full context on long context benchmarks while using 30 times fewer tokens. Large language models (LLMs) have revolutionized various NLP tasks, but processing long contexts remains a hurdle. The self-attention mechanism, while powerful, incurs quadratic computational and memory costs as sequence length increases. This poses challenges for tasks like document question answering, where context can easily exceed LLM limits. While efforts to expand context window size exist, they often come at a high computational cost. This research introduces a novel approach, learning long context offline (LLoCO), to address this challenge. LLoCO focuses on compressing long context offline and then efficiently retrieving relevant information during inference, enabling accurate responses with significantly reduced token usage. Think of it like creating a cheat sheet for an exam. Instead of bringing the entire textbook, the LLM learns to distill key information into a concise summary it can readily access and utilize. LLoCO combines two key innovations. 1. Context compression. A context encoder creates concise representations of long documents offline. 2. Parameter-efficient fine-tuning. The LLM decoder is fine-tuned using LoRa on these compressed representations to accurately retrieve relevant information to answer questions. This offline process allows LLoCO to reduce the number of tokens needed during inference by 30x while achieving a 7.62x speedup compared to baseline in-context learning methods. On several challenging long-context question-answering datasets, LLoCO significantly outperforms state-of-the-art models. LLoCO's pipeline consists of 3 stages. 1. Preprocessing. Documents are first divided into chunks. Then, a context encoder, such as autocompressor, condenses these chunks into significantly shorter summary embeddings. These embeddings act as pseudo-words representing abstract concepts within the LLM's understanding. 2. Fine-tuning. Documents are grouped based on type or task for each group. Parameter-efficient fine-tuning is applied using a LoRa adapter. This allows the LLM to learn how to effectively utilize the compressed information within each specific domain. 3. Serving. When a user asks a question, a retriever fetches the relevant compressed summary embeddings and the corresponding LoRa module. The LLM then generates answers based on this condensed information and the user's query. This approach offers several advantages. Efficiency. LLoCO significantly reduces the number of tokens needed during inference compared to using the full context. This leads to substantial cost reductions and speedups, especially for longer documents. Effectiveness. Despite the compression, LLoCO maintains or even surpasses the performance of LLMs with full context access on long context benchmarks. This demonstrates the method's ability to effectively preserve and utilize essential information. Flexibility. LLoCO can be easily adapted to different tasks and domains by fine-tuning with relevant datasets. This makes it a versatile tool for various long-context NLP applications. Experiments on several datasets, including Narrative Eka and Casper, demonstrate LLoCO's efficacy. LLoCO consistently outperforms baselines, even achieving an impressive 8x speedup and 30x reduction in token usage. Additionally, evaluations on the long benchmark further confirm its effectiveness across various tasks, including single and multi-document question answering and summarization. LLoCO represents a significant step towards efficient and accurate long context processing in LLMs. Future research directions include improved context encoders. Developing more robust and universal context encoders can further enhance LLoCO's performance and applicability. LoRa composition. Exploring methods to combine multiple LoRa modules could enable handling of diverse contexts within a single query. Handling long outputs. Addressing the current limitations when generating longer outputs, such as summaries, is crucial for broader applicability.